మేడం మీకు ఇచ్చాను హోస్ట్.
ఓకే సార్.
మేడం ఎంతమంది ఉన్నారు?
ప్రెసెంట్ 52 ఉన్నారు సార్.
స్టార్ట్ చేస్తున్నాం.
జస్ట్ ఒక 2 minutes ఆగండి సార్, వస్తున్నారు కదా, 1 minute అయినా ఆగండి. Yes, sir.
Madam.
Sir, just a minute. Good morning, students. Whenever the class is going on, another staff is going to take the attendance at any instant. So, you are informed that you have to stay throughout the session. So, not leave the session before closing the class. Sir, please go on. Strength is 7 nearby. They are joining.
Good morning.
Morning, sir.
Yeah, previously, just I need to recollect what the topics that are covered in the previous sessions. So whenever you consider the previous two sessions that are held, in that simply we consider related to the difference or definitions of power electronics as well as the linear electronics. Okay, so the single line difference between the linear electronics and power electronics is going to be the power range. So signal linear electronics deals with the signal level, which is going to be of few milliwatts to watts, where coming to the power electronics, it comes with the few hundreds of watts to thousands of watts. So the power electronics is going to be the subject which is going to have a high power ranges. Okay, so the other thing what we considered is going to be the disadvantages and advantages and disadvantages. Whenever you are going to consider the advantages and disadvantages, so the first advantage with the power electronic devices is going to be the efficiency. So you are going to have a better conversion efficiency from one form of electrical energy to the other form of electrical, that may be AC to DC or DC to AC. Okay, second thing, these devices are going to have are low cost, and the third advantage is going to be they are going to be occupying very low space, and fourth one is going to be they are going to be having a high switching frequency. All these comes under the advantages related to the power electronic devices. Okay, so majorly coming to the disadvantages. So the major disadvantage with this is they are going to affect the input power factor, first one, and second one they are going to affect that is include the harmonics in the system. Majorly these two are going to be the disadvantages with the power electronic devices which are going to be included in an electrical system. Okay, then after that we considered related to the applications of the power electronics, isn't it? So coming to the applications of the power electronics, we are going to have a numerous applications. All the sectors, that may be electromagnetic, machines, power system, signal processing, analog to digital conversion, everything, all the things are going to be related to the power electronics. So at any part of those conversions or at any part of those sector applications, power electronics is going to be included in that. Okay, that is what we considered in the previous two sessions, isn't it? So now we are going to consider the types of converters and their applications, types of devices, switching frequencies and power levels of the devices, and at last we are going to consider the signal diode versus power diode. Okay, so here firstly moving to these converters and types. So whenever you are going to consider these converters and types, okay, so before considering these converters, let me remind about the invention of the power semiconductor device. That is going to be the first device, that is SCR. So before SCR invention before 1957, all the high power switchings are going to be carried out by vacuum tubes as well as gas filled tubes. Okay, in 1957, Jordan Hall of the Bell Laboratory discovered the PNPN device, isn't it? So that PNPN device is nothing but considered to be as a silicon controlled rectifier. The characteristics of this silicon controlled rectifier is going to be having high power handling as well as switching characteristics same as that of a transistor. So it is going to be considered term to be as thyristor. Okay, so let me clear one thing. The thyristor is going to be a family, and the members of the thyristor are going to be, you are going to have PUT, UJT, you are going to have MOSFET, IGBTs, all these comes under this family. Okay, so how the name thyristor derived means, the name thyristor is going to be derived from whatever the devices which exhibits the which exhibits the power level of thyratron tube and having the switching characteristics of transistor. The combined name, by combining those two characteristics, that is high power level and switching characteristics, which devices falls under those category, those are termed to be as the thyristor family. Okay, so that is what we considered in the previous sessions. Okay, so then you are going to consider, basically you are going to have five types of converters. Basic converters are going to be the basic power electronic converters are going to be five types. Out of these five types, you are going to have, when you are going to have AC to DC conversion, DC to AC conversion, DC to DC conversion, as well as at last you are going to have AC to AC conversion. Okay, if you are going to consider the first one, that is going to be the AC to DC conversion, this AC to DC converters are going to be nothing but termed to be as the phase control rectifiers. Okay, so simply AC to DC converters are termed to be as the rectifiers, isn't it? These rectifiers are going to be again classified to be as controlled rectifiers, uncontrolled rectifiers, depending upon the power electronic device employed. Is it clear? So which, depending upon which type of power electronic device employed, the devices are going to be classified, the converters are going to be classified to be as AC, to be as controlled rectifiers or uncontrolled rectifiers. Okay, so what the major applications of these phase control rectifiers or rectifiers are going to be these here. Okay, you are going to have a high voltage DC transmission system. So high voltage DC transmission system is going to be considered as, it is going to be economical for large power transmission over a large distance. Okay, so one of the major applications nowadays employed is going to be the HVDC transmission, which is going to have a range of around 1400 kilometers, having a range of 1400 kilometers at a power level of 800 kilowatts, like that. Okay, so the second major application is going to be the DC motor drives. These DC motor drives are going to be majorly employed in the industries due to the linear characteristics between the speed and torque. So as they have linear characteristics between the speed and torque, the control of the motor is going to be quite easy when you are going to consider a DC motor rather than the AC motor. So almost most of the drives, industrial drives, are going to be provided with DC motor drives when a particular speed control is going to be required, and the other one is going to be the regulated DC power supplies. So as you know that regulated DC power supplies, most probably they are going to be employed in domestic applications as well as testing labs, everything like that. Okay, so coming to the other, that is static VAR compensator. So in the last class we had seen an application related to the static VAR compensator. We had seen a video related to the static VAR compensator. So the purpose of this static VAR compensator is to compensate the reactive power on the transmission networks. Okay, so wind and generator converters, as you are going to have the generated power to be as the power generated by the induction generators in the wind turbines are to be matched with the grid frequency and power levels, then power electronic converters are going to be employed. And at last, that is the battery charger circuit. So in the inverters, when you are going to consider majorly in the inverters as well as mobile charging, laptop charging, all these are going to be provided with the battery charging applications, and you may consider these to be domestic as well as industrial charging circuits. Okay, so majorly phase control rectifiers are going to be having a major applications of all these areas. Okay, so coming to the other, that is going to be the DC to DC converters. So what is this DC to DC converters means? In some applications we need to control, in some applications we need to have a change in the DC power level. Okay, so the DC power level may be lower value or maybe in higher value. So that means if the DC available voltage is going to be 200 volts DC, then we need to provide for an application a voltage level of 50 volts or a voltage level of 80 volts or a voltage level of 150 volts, like that. Okay, in that case, then these converters are going to be, these chopper circuits or DC to DC converters are going to be employed. Okay, so here this chopper circuits may be of volt reduction in the voltage level or maybe of increase in the voltage level. They may be termed to be as step down chopper circuits, step up chopper circuits. So this step up and step down are going to be completely based on, step up and step down are going to be completely based on the DC magnitude available on the output of the converter. Okay, so the major application for this are going to be this. The first one is going to be the DC drives. Okay, so you are going to have a motor drives, you are going to have DC motor drives. So in the DC motor drives we need to provide a variable DC voltage. So the best example and a simple example for this is going to be speed control of a separately excited DC motor, in which we need to provide the voltage to the armature, variable DC voltage to the armature. Okay, suppose if we need to consider the motor to be operated at half of its rated speed, then we need to provide half of the rated voltage, isn't it? That can be attained by using this chopper circuits. Okay, so the other is going to be the subway cars, battery driven vehicles, and the electric traction systems, and at last is going to be the switched mode power supplies, SMPS. So the switched mode power supplies are going to be majorly employed in uh, Xerox machines, PCs, your personal computers, everything is going to be employed with this. What is the switched mode power supplies means? Whenever there is a requirement of multi voltage levels, so it may be 6 volts, 12 volts, 30 volts, 15 volts. At that case, these circuits, or a circuit is going to be considered for providing these variable voltages: 6 volts, 3 volts, 6 volts, 12 volts, 15 volts, 30 volts. All these are going to be provided by switched mode power supplies. Okay, so is it clear with the chopper circuits? Okay, so basically choppers are going to be DC to DC converters. So this DC to DC conversion is going to be providing the change in the magnitude of the DC voltage at the output of the converter. Okay, so coming to the other converter, that is going to be the DC to AC converter. DC to AC converter, where these DC to AC converters are going to be employed means, when you are going to consider the universally available utility system, the universally available utility system is going to be AC, alternating current. Can we store the alternating current in any form? So as the polarities of alternating, as the cycle is going to be having a positive half cycle magnitude and a negative half cycle magnitude, then ultimately we are unable to store this AC voltage. So ultimately we need to store the voltage in the chemical form or any other form in the base on the basis of this DC. But our applications are going to be completely related to the AC. You are going to have an induction motors, you are going to have an induction machines, you are going to have a motors, refrigerators, everything operating for AC. So ultimately we need to convert the stored energy, DC stored energy, to that of AC, which is going to be done by this inverters. Okay, so majorly you can consider the applications in the UPS or inverters, home inverters or UPS. Second one, aircraft and power supply systems. So they are going to have the inverter circuits which are going to be providing the AC voltage at a frequency of 300 Hz, 500 Hz, depending upon the application requirement. And coming to the other, that is going to be the induction and synchronous motor drives. So induction and synchronous motor drives, in that case we need to operate the motors by changing the frequency or change in the voltage level. All those are going to be provided by means of this inverter circuits. And high voltage DC transmission systems, high voltage DC transmission systems, and at last is going to be the induction heating supplies or applications. Okay, so inverters are going to be whenever we need to store the electrical energy, then ultimately AC form of energy is to be stored to convert to DC, which is the front converter considered to be as a rectifier, and the back end converter is going to be always an inverter for converting the DC stored energy to that of AC. Okay, all these two are going to be employed in ultimately in the UPSs. Okay, then coming to the other, that is going to be the last one, that is going to be the AC to AC converters. So in this AC to AC converters, you may consider two types of converters. One is going to be the AC voltage controllers or regulators, and the other one is going to be the cyclo converters. Okay, so what is this AC to AC voltage controllers means? These are going to be the converters which are going to be providing the voltage, which are going to provide the change in the voltage without any change in the frequency. Suppose if you are going to provide a single phase AC voltage of 230 volts single phase AC voltage to the converter, then this particular converter is going to provide a voltage of 50 Hz, 30 volts, 50 volts, 100 volts, 150 volts, 200 volts, like that. Okay, that means we are able to control the voltage magnitude. We are going to control the voltage magnitude based on the switching devices. So whenever the magnitude of the voltage is going to be controlled, then it is considered to be as a AC regulator. Then it is considered to be as a AC regulator or AC voltage controller. Okay, so the major applications for this is going to be the lighting control, industrial speed control of large fans and pumps, and electronic tap changers. Okay, so then coming to the other, that is going to be the AC to AC converters. So these AC to AC converters, they are going to have change in the magnitude as well as the frequency. Okay, so whenever we are going to consider an application of induction motor speed control, induction motor, the speed control of an induction motor can be varied by providing a change in the frequency as well as the magnitude. That is going to be considered to be as V by F control as well as I by F control in the induction motors. So basic controls of an induction motor drive are going to be V by F control as well as I by F control. What is this V by F control means? Voltage to the frequency change. Second one, I by F control, that is current to the frequency change. Those change in the frequency or those change in the voltage can be provided by these converters, cyclo converters. Okay, so cyclo converters are going to majorly have the applications of AC drives. So this is related to the types of basic types of converters employed. All these converters are going to be, we are going to consider all these converters in the basic terms of operation. You are going to have a phase control rectifier, DC chopper, you are going to have an inverter, you are going to have a voltage regulator. all these are going to be considered for basic operations, and all these converters are going to be having an advanced conversion topologies. Okay, so beyond this, if you are going to consider the converters beyond this, then you are going to have uh, different types of converters which are going to be the advanced, that may be considered to be as a zero voltage switching converters, zero current switching converters, sepec converters, multi-level inverters, all these. So all these comes under the advanced versions of these converters. Okay, is it clear? Okay, then moving to the other topic, that is going to be power electronic switching devices. Okay, what are these power electronics switching what are these power electronic switching devices? So you are going to have a numerous power electronic switching devices. How they are going to be classified? They are going to be classified on the basis of controllability. So what is this controllability? Means if a power electronic device is going to be turned on and turned off by the power circuit itself. Okay, here you are going to have two circuits in the case of power electronic switching devices. One circuit is going to be the power circuit, which is going to be connected between the two power terminals of the device, that may be anode and cathode, or metal terminal MT1 and MT2 for various devices. Okay, so the power electronic switching devices are going to be classified to be as on the basis of their controllability. What is this controllability? Means if the device is going to be turned on and turned off by the power circuit itself, then that device is considered to be as an uncontrolled turn on and turn off device. Okay, so if you are going to consider a power diode, the power diode is provided with the terminals anode and cathode, isn't it? Anode is going to be having anode. If anode is made positive, more positive than the cathode, then the device conducts. If anode is made lower than the cathode, then the device is going to be in the reverse blocking mode, so the device is going to be the off state. So that particular condition is considered, whatever the devices those comes under that particular condition, those are termed to be as uncontrolled turn on and turn off devices. Uncontrolled turn on and turn off devices. Okay, so the best example for that one is going to be the power diode. The best example for that one is going to be the power diode. Okay, so coming to the other, that is going to be the controlled turn on and uncontrolled turn off devices. Controlled turn on and uncontrolled turn off devices. So here, if you are going to consider these devices, in these devices, though the power circuit is going to be favorable, that means if we are going to apply higher potential to the anode and lower potential to the cathode, the device simply going to be in the blocking mode. But whenever a control signal is going to be applied, then the device comes to the conduction. Those devices are termed to be as a controlled turn on and uncontrolled turn off devices. Okay, so on a single line, we may consider these power semiconductor devices to be as controlled devices and uncontrolled devices. So as the devices are going to be provided, as the devices are going to be provided with two switching instants. What are those two switching instants? One is going to be the turn on instant and the other one is going to be the turn off instant. So if the turn on instant and turn off instant both are going to be controllable by a signal, by a control signal, then those devices are considered to be as a controlled turn on and turn off devices. So this comes here. You are going to have third one, controlled turn on and turn off devices. So in this controlled turn on and turn off devices, both the turn on and turn off of the devices is going to be controlled by a external control signal. Example for this is going to be the power transistor, BJTs, MOSFET, GTO and IGBTs. Okay, coming to the second one, controlled tone on and uncontrolled tone off. These devices comes under controlled tone on. That means we can able to simply make the device tone on by a control pulse, but the tone off is going to be dependent on the power circuit. Power circuit. Those devices are termed to be as controlled tone on and uncontrolled tone off devices. One of the best example for this is going to be the thyristor. Okay, so majorly depending upon the controllability, the switching devices are going to be classified to be under these three categories: uncontrolled devices, controlled tone on and uncontrolled tone off devices, and at last controlled tone on and tone off devices. Okay, so this third which we are going to consider is also called as a controllable switches. Whatever the devices coming under this category are considered to be as the controllable switches. Okay, so uncontrolled devices, controlled tone on and uncontrolled tone off devices, and the third one is going to be the controllable switches. Okay, you may have the examples of these coming under these categories. Okay, so then again they can be classified to be as controlled gate signal, pulsed gate signal, depending upon the gate signal required. What is this gate signal means? This gate signal or a control signal is going to be the signal which is going to be applied to the control terminal. You will get much familiar with this control terminal or control signal or gate signal when you are going to consider the characteristics of an SCR. Sorry, when you are going to consider the device terminals of an SCR. Okay, so the another classification for the devices are going to be continuous gate signal required devices, pulse gate required devices. Okay, so continuous gate signal required devices means BJT, MOSFET, IGBT. So for an example, all these devices require a continuous pulse, means you are simply going to provide a current. You are simply going to provide a current to the control terminal. The device comes to the conduction. Whenever you are going to remove the control pulse or you are going to remove the control signal, the device comes to the blocking state. Okay, so that is in the case of this controlled signal devices. And coming to the last, that is going to be depending upon the current capability, devices are going to be classified to be as bidirectional current capability and unidirectional current capability devices. Okay, so these majorly you can consider these depending upon the controllability, depending upon the gate signal, depending upon the current carrying capabilities. Okay, then uh, before moving to the current and voltage ratings, you may consider these. So these are going to be the physically the devices which are going to be available in the market. That is going to be the power diode packagings. Okay, so the power diode which is available is going to be in these structures like this, in these packages. Okay, so this could be depending upon the rating, their structure are going to be changing. So here the one terminal provided here is going to be the anode, and the other terminal provided here is going to be the cathode. Okay, you are going to have anode and cathode provided. Always the anode terminal is going to be connected. Always the anode terminal is going to be screwed to a heat sink for heat dissipation. These are going to be this is going to be the conducting terminal, and this is going to be the conducting terminal in which you are going to have a PN semiconductor device, semiconductor materials fabricated over these metal studs. Okay, this is going to be the power diode packagings available for the power diodes. And coming to the SCR packagings, you are going to have different types of SCR packagings. Okay, so for low power applications, you are going to consider these two SCR types. Okay, for high power applications, you may consider any of these SCR packagings. So here you are going to have three terminals for the SCRs. Okay, one is going to be the anode, cathode, and the other one is going to be the gate terminal. Okay, that is that you can get familiar when you are going to consider the device representations, device structure. Okay, so these are going normally these are going to be the characters, these are going to be the packagings available for the SCRs. So for small applications these two may be considered, For high applications, these three may be considered. And you may have another form of representation for the semiconductor SCR for high voltage levels of 10 kV, 20 kV, 50 kV, like that. Okay. So the other is going to be the MOSFET packagings. So these are going to be some of the packagings available for the MOSFET device. Low power applications, high power applications, like that. Here always these devices are going to be provided with a heat dissipating terminal. One side of these terminals are going to be provided for heat dissipation. Always this terminal is to be provided connected to the heat sink. Okay. So these are going to be packagings for the MOSFET device. Okay. Then here, coming to the other, you are going to have the semiconductor device power ratings. Okay. On a brief, I will conclude this in 2 minutes. Okay. So you are going to have the power diodes. Okay. General power general rated power device is going to have a voltage rating of around 4000 volts and 4500 amperes. Okay. Which is going to have an operating frequency of 1 kilohertz and having a switching time of 50 to 100 microseconds. Okay. And coming to the what we need to observe here is going to be the on state resistance. Here the on state resistance provided is going to be 0.32 milliohms. 0.32 milliohms. So that means if it is handling a voltage of 4000 volts and a current of 4800 amperes, having an on state resistance of this provide a very less voltage drop across the device. That could be less than 10 watts, 10 va, 10 watts, or like that. Okay. So the general purpose diodes are going to be having rating from 2800 volts to 4000 volts with a current rating of 4500 amperes to around 1700 amperes. Okay. Coming to these high speed power diodes, these are going to have a switching time span from 5 to 10 microseconds to 0.2 microseconds. 0.2 microseconds with a voltage rating from 150 to 4500 volts and a current rating from 80 amperes to 1950 amperes. Okay. So when you are going to consider the resistance value for this is going to be 8.63 milliohms, 0.41 milliohms and 1.96 milliohms. Okay. This is related to the power diodes. Okay. Similarly, you are going to have MOSFETs, which is you are going to have the bipolar transistors, which are going to have the operating voltages from 1200 volts to 400 volts, handling a current of 250 amperes to 400 amperes and having a resistance value of 4 to 10 milliohms, isn't it? Okay. Then you are going to have the thyristors. In these thyristors, again, they are going to be classified to be of phase control thyristors, forced tone of thyristors, self-toned of thyristors. All these are going to be based on their application requirement and controllability. Their voltage levels are going to be from 6500 volts to at least of 4500 volts. So in between, a thyristor can be employed with a current rating of 4200 amperes to 3 to a range of around 3000 amperes, having a switch resistance values of these and switching times. Okay. So all these are going to be the voltage ratings. This is going to be updated future. At present, these voltage levels are going to be updated to a higher values, which may be up to double when you are going to consider the present packaging devices. Okay. Then we need to consider the other. This simply schematic representation represents same the previous voltage ratings in a graphical form. So here on the x-axis you are going to consider the operating frequency in hertz, and on y-axis you are going to consider the power handling capacities. So 10 volts, 100 volts, 1 kilovolt, 10 kilovolt up to 100 megavolts, and you are going to have an operating frequency from 10 to 1 megahertz. 10 to 1 megahertz. Okay. So devices triac is going to have an operating range from 1 kilo volt VA, and SCRC is going to have an operating of beyond 10 mega VA, and you are going to have an operating switching frequencies for different applications. So for HVDC application, for traction applications, for UPS applications, for motor control application, for welding applications, hybrid vehicles, and electronic application. This simply represents the operating frequencies and power ranges. Okay, then coming to the last, that is going to be this difference between. So you may have a question now, how these voltage levels are going to be increasing, and what could be the difference between how their handling voltage levels and current levels are going to be increasing. That is simply based on this difference. Okay, that difference is going to be uh, on the construction itself. So if you are going to consider the simple signal diode, it is provided with a p-type n-type material, provided with an equal doping of p-type and n-type material, having a two terminals of anode and cathode, isn't it? Okay, coming to the power diode. In the case of this power diode, you are going to have a p material which is going to be of heavily doped. Okay, along with this p type, you are going to have two layers of the n type. So out of these two layers, one is going to be a lightly doped n layer and the other one is going to be a heavily doped n layer. Okay, this particular n layer, which is going to be considered to be as the depletion region, this makes the difference between a signal diode and a power diode. Okay, so signal diode is going to be differed from a power diode by this particular characteristics. So you are going to have an n layer. The thickness of this n layer, the n minus 1 layer, lightly doped layer, is going to provide the difference in the blocking voltages. Okay, so you can consider that is both are going to have the same operating principle, same terminals, that is the anode and the cathode, but the difference is going to be the power diodes are going to be provided with an additional layer which may be considered to be as a depletion layer, and it is going to be with a lightly doped n layer. Okay, so mostly the time is up. We may consider clearly related to these power diodes in the next session. Is there anything doubts or anything needed related to the topics discussed now? Anyone can respond.